Maybe so. Hold on, I gotta pee. Woo! Man, legs. Golly. Oh. Oh. No, I'm not brushing my hands at it. Let me order my damn tropical smoothie before I get mad. This why I need to stop sitting down so damn long. I can't even walk now. Golly. Oh, I need to review my... While we doing our lunch date at Tropical Smoothie, we can review our trigonometric functions. Oh, Lordy. I'm gonna get me a Blimey Limey again. That was actually good. With a chicken quesadilla. Beautiful. Let me add in my free supplement. And let me add in my free cookie. Oh, I can't. Okay. Declined. Oh, Lord. Oh, hell no. My shit ain't even sticky no more. Oh, my gosh. I don't even have no damn money. I don't even have no damn money. I can't believe this one. I cannot believe this one. I really can't. This is something I can't believe. This is something I can't believe. Oh, hell no. You doing 35 and oh, hell no. Oh, motherfucker. Oh, hell no. Speed the fuck up. Damn. Gotta get real again. You got shit to do. Ugly ass fucking car. Oh my god. Hell no. You got this. And I got bitches. You got this. No! And I got bitches. My gosh. You got me out the trap. Take me off the mark. Take me off the map. I'm trying to hit the group chat and tell them it's a come and rescue me. Take me out the club. Take me out the trap. Take me off the market. Take me off the map. I'm trying to hit the group chat and tell them it's a rap.
A BetterHelp ad. October 10th is World Mental Health Day. And this year, we're saying thank you, therapists. Behind every supportive moment and small win is a therapist who showed up and made a difference. BetterHelp has supported over 5 million people globally on their mental health journeys. With 12
Shut the fuck up! I'm so motherfucking irritated. I think I'm just hungry, honey. I'm so... Go in here and fuck this test up. Okay, so the derivative of sine is cosine, which would mean the antiderivative of sine is negative cosine. Right? Or yes. The derivative of sine is cosine, and the derivative of cosine is negative sine. And the derivative of tangent is secant squared. And the derivative of cotangent is negative cosecant squared. And the derivative of secant is secant x tangent x. And the derivative of cosecant is negative cosecant cotangent. And the antiderivative of tangent is natural log of x plus x, right? Natural log of secant x. That's not right. Okay. Style lasted, honey. Okay. Okay. Let me drink some of my smoothie. Maybe this will put me in a good mood. I'm so hungry. Maybe that's why I'm a little grumpy. Yes. Yes, yes, yes. I'm finna fail this damn quiz and they want to play this song.
How I'm feeling, it doesn't matter, 'cause you know I'm okay. Instead, I ask myself, why do you worry? You know I'm the same. No, I know you're gonna love me, baby. Trying to take you away from me, falling over my dead I think I killed everybody in the game last year, man. Fuck it, I was on though. And I thought I found a girl of my dreams at the strip club. Fuck it, I was wrong though. Shout out to all my niggas living tax free. Nowadays it's 6 figures when they tax me. Oh well, guess you lose some and win some. Long as the outcome is income. You know I want it all, and then some. Shout out to Asian girls, let the lights dim some. Shots came, I don't know where they were sent from. Probably some bad hoes I'm about to take a hint from. Yeah, you know me well, nigga. Yeah, I mean, you ain't the only real nigga. They got me on these white women like seal, nigga. Slave to the pussy, but I'm just playing the field, nigga. Yeah, all these people really discussing my career again. Asking if I'll be going platinum in a year again. Don't I got this shit the world wanna hear again? No Michael Jordan still got his hoop earring in. Man, all of your flows bore me, paint drying. And I don't ever be tripping off of what ain't mine. And I be hearing the shit you say through the grapevine. But jealousy is just love and hate at the same time. Yeah. It's been that way from the beginning. I just been playing, I ain't even noticed I was winning. And this is the only sound you should fear. Man, these kids wear crowns over here and everything is alright. I know you don't love me, baby. They're trying to take you away from me. Oh, me. Oh, my dear. You say I'm old news, well, who the new star? Cause if I'm going anywhere, it's probably too far. Just performed at a bar mitzvah over in the States. Used half of the money to beat my brother's case. Red wine over fair time. But shout out to the niggas that's doing dead time. And shout out to the bitches that...
You're a little late, but we made it.
You gon' forever be mine.
Oh! Lord have mercy, what the fuck she looking at? Ugly fat weird ass. Have mercy, what the fuck she looking at? Ugly fat weird ass. Yes, yes, wish me luck. Wish me luck if you dare. Ooh, I'm not even gonna try and walk fast. Wish me luck if you dare. Ooh, I'm not even gonna try and walk fast. If you dare. If you dare. Ooh, I'm not even gonna try and walk fast. Ooh, she called somebody a punk. She said punk. Thanks for all the luck wishes, the good luck wishes. My phone feel like this. Man, I should have put some lip gloss on. My damn lips dry as shit. Thanks, sisters. Thanks, sisters. Thanks, sisters. Ooh, it's homecoming. Midterm mania. The Wi-Fi is insane. I'm connected to it. It's not good. It usually good. The Wi-Fi is insane. I'm connected to it. It's not good. It usually good. Oh. Look, y'all. Look. Cute. Stop calling him up. Did somebody leave their ass in the hallway? What the hell? Wait, is it school? Do we got school today? Look at all this shit. Why everything closed? Wait a minute. Do we got fucking school today?
I have the voluntary functions. Let's go sign. Alright, so I suppose the big plan for today was to just go over problems from this little practice sheet thingy. So before I start randomly doing problems, are there any ones in particular that you want to go over? Because there are some tricky ones on here.
Do that one.
Do that
The 1 minus cosine 4x under the square root.
Okay. Yeah, I think we can split the day, half and half, do half me doing stuff, half you guys doing stuff. Sounds right. Zero to pile here. And it's one, that's actually really one.
Oh, so we wasn't supposed to do this at home?
It was sort of up to you.
Okay.
You know, I kind of advertised today sort of as like a self-study, aka get help from me whenever you need it kind of problem, or kind of day. So I'm gonna, you know, spend the first half just going through individual problems that people want me to go through, or something like that, and then second half, you know, people who haven't done any of these can get some time doing
Yeah.
them in class. But if you have already gotten the majority of them done, you're kind of like, that's our plan for today.
Okay.
All right, this one is a good one. We do want to use trig identities on this thing. And the trig identity that I want to use on this thing is very, very close to this one. Or at least this is the one that I'm going to force to fit into this particular format.
You can unpower these things?
Yeah, so this is the power reduction identity. And in particular, if I'm taking a look inside the square root, I see that I almost have the power reduction identity, the right-hand side of it. There are a few key changes that we need to make. One, we have a 4 here, not a 2 inside the cosine. And we're missing our divide by 2. So the divide by 2 is the easiest to fix. I can multiply and divide by 2 and get my division by 2. And then I can even do some algebraic stuff, pull the 2 outside the square root of square root 2 and pull it out. The last thing that we really need to fix is the fact that I have 4x here and I have 2 theta here. Yep, so I replace theta here with 2x. I get 2 times 2x in the second cosine. And then now I can make my little substitution. This thing inside the parentheses is sine squared of 2x. And now we can sort of do usual shenanigans. Pull out square root 2. I have a square root of a square. And now I just need to integrate this thing. What's my inside derivative of sine of 2x? -1/2 cosine 2 pi.
Are we still evaluating? It's just algebra technically instead of substitution?
Yep. We have not changed our variables here. Right, we started with x, and then we still have x. We just applied the trigonometry. So let's see here. Top limit is going to be cosine pi over 2, which is 0, and then bottom limit is going to be cosine.
Girl, shut the fuck up.
Which is
With your ugly ass.
Yep. So I believe this is root 2 over 2.
That's what I got.
Good. Was it here to here, America?
Yeah.
It's a tricky one. You kind of need to sort of use this power reduction identity, but sort of in reverse of what we have been using it.
He got a question.
Yeah, what's up, Xavier?
Just separate. So I was wondering about the use trig subset value following integrals, and it was the last one, I believe, the 2 to 9.
This one?
Yep.
Sure.
I'm gonna go home. I already did all this.
Squared minus 1. So Xavier, if I can ask, what
I think that's secant, but the 3 over 6b, that's applying a total.
It's not today.
So that's x squared minus 1.
x squared, or square root of x squared minus 1.
Yeah, which I don't know how that applies to its identities.
Now let's go ahead and just start out with secant substitution. So this is my x substitution, and dx.
Ain't nothing wrong with you. Fuck
What's
that.
the root of secant?
Fuck that.
Secant tangent. And we're also going to need to do a little bit of shenanigans with our lines. Also, I did something silly there. I'm being very I think this is working. Yeah. Yeah.
Even though I got my own TV.
Lower limit, upper limit
My own TV.
is 2 equals secant theta and 9 equals secant theta. And this is where we sort of have a little bit of a weird thing going on because we're going to be taking the inverse secant on both sides. And these are very likely going to be like the opposite of this. As far as I'm aware, these are not on the exact value chart, or at least this one definitely isn't. This one is.
I think we just wait till that's up.
Yeah, that's what my recommendation is.
Can you make it one with a cosine and then multiply cosine, both sides by cosine?
Yeah, this one I think is where cosine is equal to 1/2, which is pi over 3.
Yeah, fine.
We know at least this one. This one seems like it's going to be complicated. So we're going to wait and X up. So we're gonna instead choose to just do this. Okay, Xavier?
Yep.
Alright, let's make all of our various different kinds of substitutions. Up top we get secant, theta, tangent, theta, d theta. Down below I have square root, parentheses, cube, secant squared, theta,
The cube doesn't go under the discriminant.
under the square root.
Yep.
No, it doesn't supermatter, right? Because it's multiplication, so they can put it on. What's secant squared minus 1? Tangent squared. What's square root of tangent squared? Tangent. We get secant theta over tangent squared. And now we gotta integrate this stuff. I'm gonna sort of rewrite this down in terms of sines and cosines. So let's see here, we got 1 cosine theta and secant. We have tangent in the denominator. So we got that. Cosine's gonna cancel. And after all that work, we have cosine over sine squared. Take a second to think about this new integral, and you're gonna do that one. So,
No.
No.
Maybe.
why do you say no, Zach?
Because there's an easier way to write cosine over sine squared into a known derivative of a trigonomic function.
Okay. But this sort of requires that everyone has that knowledge. Which is good that you know it, right? You're thinking of taking this and saying it's cosecant, right?
Cosecant on cotan, and then the antiderivative would be negative cosecant.
Yeah. But let's suppose that Xavier doesn't have that. Is that fair to say, Xavier?
Is he talking about taking cosine over sine and then just leave the sine? Oh, 1 over sine? Is that what
Yeah,
you're talking about?
rewriting this to be cotangent
Mhm.
with a cosine and a sine times a cosecant. So we have
That's what I got.
cosecant cotangent.
Tangent? No. Oh, wait, no, it's reciprocal because it's 1 over tangent. Then turn it into cut. Okay, yeah.
But you still would have to do so let's just do this. What's your unit? And your du then is
Negative cosine. Just cosine. Just cosine.
remember derivative of sine is cosine, antiderivative of sine is negative cosine. Where do you so this is u squared down below.
That's
So it'll be derivative.
yeah.
You want to raise the power by 1 into that. And then x up. do the final back sub or get into the So what Zach was talking about was up here instead, right? That says cotangent, cosecant. And one of the derivative rules you got in calculus includes the derivative of cosecant. We're missing the negative, so we gotta fix the negative on the antiderivative side. Because derivative of cosecant is negative cotangent cosecant.
I do not remember that derivative, so I would have just did 2 separate for calculus.
Is why I was sort of curious why Zach was so adamant about no.
I mean, same answer. What I find the first way easier.
Yeah, it's sort of up to you in your memory of like these various different kinds of derivative rules. Right? I would be perfectly happy if you went from there to negative cosecant. If you're a little more step of going to secant or cosecant, cotangent. But that being said, not everybody remembers that stuff. All right, we have our antiderivative in terms of theta. It's negative cosecant. Technically speaking, I suppose we should get a plus C, but we are evaluating a definite interval. So that plus C is not really going to supermatter. What I need to do is I need to take negative cosecant of theta and rewrite it in terms of x so I can plug in into it. How do you back sub and trick sub? Use the original sub and do what with it?
Turn in some just sine, cosine, and back to what you need.
Do what you need. That's sort of what I'm asking about. What do you need?
You need sine without cosine. I do not remember how oh, wait, negative one? No, that's a squared.
You gotta make a triangle.
You gotta make a triangle.
Oh, yeah, triangle.
Right. Cosine is what ratio of sides in the triangle? Adjacent to hypotenuse. So adjacent side is 1, hypotenuse.
Period. The queen be knowing.
We want sine.
The queen be knowing.
Which one's sine going to be?
The opposite.
Opposite over hypotenuse. So I want this side. I'm going to get that side. I'm going to call this b 1 squared plus b squared equals x squared. B equals square root squared minus.
The queen be knowing.
Yeah, sine is opposite over hypotenuse. Cosecant is going to be hypotenuse over opposite.
Oh, no, it's,
Wait, that backwards. Hypotenuse over opposite.
that's over the square root of square.
Minus 1. Yep.
We plug in 2 and 9.
Remember to make negative. Now we plug in 2. So let's see here, this is what? 9 over the square root of 81 minus 1, so it's square root of 80.
When we just square root over 80, or what's next?
Was that 4 times square root of 5?
Mm-hmm.
Yeah. Okay.
That's what I got.
Yep. So we have negative 9 over 4 root 5. And we plug in 2. We get 2 over root 3. I don't think that's really a whole lot we can do about that one.
Root 5.
4 root 5.
Thank you.
2 squares. Is that, oh, minus 1. All right, never mind.
Unless I'm crazy, but I'm pretty sure that's minus 1.
I saw the plus still from the earlier.
This crazy one.
Even though I got my own CD.
I don't think there's a good meaningful way of simplifying that over.
Minus and minus.
Yeah, it's minus and minus.
Oh, yeah, it is.
Right, the original one had a negative in it when we got to subtract the little font.
Could you talk us through how you did that in your head from square root 80 to 4 and root 5?
So it was all about breaking up that 80. 80 is 8 times 10. And 8 is 4 times 2. And I have a square root here, and I know I can pull up that 4 as a 2. The 10 is also 2 times 5. So I get 4 times 4 times 5. So you can pull out that second 4 as a 2, you get 4 root 5. That's what I was doing in my head. I don't know, is that what you guys were doing in your head?
Yeah, I did, 80 is 8 and 10, and then I multiplied by 2, I got 16 and 5, and then square root of 16.
Yeah, that's cool. That being said, I don't think I would be terribly upset if you left it as negative 9 over the square root of 80. Really good one. Lots of moving parts. A willful decision to wait on the back substitution. It was a good one.
I have one more question.
Yeah.
When you did U sign and du, did you say that it's a negative?
No. You're talking about here, right?
Never mind.
Right, antiderivative of sine is negative of sine. We want derivative.
Even though I got my own CD. My own.
Good, Xavier?
On that one, yes.
That one? Okay, do you have another one?
Yeah, but does anyone else? I'll go.
There's another one here that I think is like pretty tricky. Actually, there are 2 other ones that I think are particularly kind of tricky.
On the trig stuff?
No, just on the sheet in general.
Oh, in that case, my other one was on the partial brackets right below the bottom right one. The one with E and everywhere. Is that the one you were thinking about or not?
This one?
Yep.
Yeah, that is one.
Wait, which one you just point at? The e to the 2x one?
Yep, the one.
We finna use you said.
U sub? I mean, you will need partial fractions eventually, right?
Mm-hmm.
It's down right.
That's chance. Do you even cover what you're doing back then as much, or is it just like,
You're gonna hate me for this answer, Xavier.
is it something we did but you didn't tell us we did technically?
It's something you should have done back in pre-calc.
Ooh. Okay.
So me, with my infinite knowledge of all things pre-calc, I am going to forget to write my dx. But more importantly, I'm going to rewrite these products in my exponents as exponents of exponents.
Yeah.
And the other thing that pops out to my eyes after I've done this is, boy, that denominator sure looks like, and this is the pre-calc topic, it sure looks like a quadratic form. It looks like a quadratic, but like maybe we have to squint our eyes a little bit to pretend like it's a quadratic.
Something to square then.
Plus constant times that thing that was squared plus the constant.
I guess.
This is a quadratic form. And if you remember your pre-calc, the way that you treat quadratic forms is to do what pre-calc?
What, do you say?
Yeah, do a system.
Mm-hmm.
It's not the in particular, you want to make the variable for the quadratic just a regular old variable. So I'm going to let u equal e to the x. And when I do that, I get this. And as Calc 2 students, there should be something in here that should dismay you significantly. My variable inside the integrand is u. The thing I'm integrating with respect to is not u. So we gotta fix that. This is still the key. Functions. And then now I can differentiate them and get my differential. Dx is 1 over ut. Either order. You sort of have two different ways of thinking about this, which I suppose are technically different, but not super different. One of those ways is to just go straight for factoring, so we're looking for two numbers that add to 16 and multiply to 63. 7 and 9. And then we can go into partial fractions from here. All right, I have degree 3 in the denominator, degree 2 in the numerator. Or alternatively, I have a factor of u up top and I got a factor of u down below. And cancel them right now. And then factor that denominator. These two are equivalent because when you actually go and do your partial fraction decomposition on this one, you're gonna find that the number, the constant, on top of u is 0. But as of this point, it is partial fraction decomposition. When you get your u antiderivative, just remember to max up u is equal to e to the x. This one was the one we had to treat.
Yeah.
There, you found the substitution. Did you treat the dx? How did you treat the dx?
Let me look. I probably ain't even make it that far, but I know I picked e to the x as u,
Okay.
and then I went from there. But let's see.
Could you, like, in your brain, like, keep in mind that e to the x as, like, without, like, substituting it and factoring it? Would that work with fraction? So you have to do e to the x and then e to the x plus 11 times e to the x plus 9.
Yeah, that'll work. It's totally equivalent to what we've done, and I think, well, it's mathematically equivalent to what we've done. On the right-hand side, you're definitely going to be more right. But, if that's something that's care about, then it doesn't seem to matter. Like, it's mathematically equivalent.
Then you wouldn't have to worry about the,
You do need to use sub at some point.
so we can't do, fractionation or
Partial fraction.
partial fraction.
You can, but you're still going to find certain difficulties with that e to the x. Once you get done with partial fraction decomposition, that is when you're going to need your u sub. You can either do that with the e to the x's laying around right now and just kind of ignoring their existence, or you can do the substitution first and then get rid of them. But you will need u sub eventually.
Okay, so you will run into a problem at some point.
Yeah. You would essentially run into the problem of after this partial fraction decomposition, you're gonna have some u's in the denominator that you can't immediately get rid of without some kind of partial, or without some kind of u sub.
Okay.
Yeah, Xavier.
So that, you substitution, we change the x to the lower stuff.
Yeah.
How do you connect these ways and say, du is just e to the x and take, e from the numerator?
That would work.
That would work just fine. Okay.
It's I mean, in all things mathematical, it's equivalent, but I think of it, me, myself personally, I think of it as nothing that keeping track of anything else is bad. Instead of like trying to just get rid of things. You know, if that makes more sense to you, go ahead and do that. It's equivalent. All roads lead to Rome, as they say. That's a phrase you've heard before, right? I would just kind of date myself with that one.
Oh, no, it's just, returning a joke right now. People are like putting it everywhere. I mean, it's not relevant. But it is relevant here. It's kind of reverse stating yourself.
Okay, I wasn't aware that I was doing reverse stating myself, but okay. Any other ones? still think there's one more tricky one.
Arc sign one? I don't know.
The arc sign one.
You're passing it. It's on the very bottom.
Oh, this one?
Okay, we can leave that. Just use that.
Yeah, that one's just use some.
Yeah, I was just trying to figure out which one you think is harder for us.
Now, if you remember your derivative of arc sine, which hopefully everyone does, that one should be pretty apparent that this one's u sub. U is arc sine, du is 1 over the square root of 1 minus x squared dx. So this would very quickly turn into the inside derivative of x times dx, or times yeah, derivative. The other one I think that is tricky is this one. Because it's not 1 plus tangent squared, it's quantity 1 plus tangent squared. Well, we only got about, 45-ish minutes left, I think. So I think we can transition here to some self-study time. Yeah, Xavier.
Question. That one, not just boil and then do partial reckoning, not partial reckoning, transition. The one where we're getting rid of power reduction.
Let's write it down. So what were you saying to do first, Xavier?
Foil, change everything to the sign, cosine, power reduction, probably a lot of it.
Okay,
So
so
start you subbing. Am I crazy?
foil it out. Now change everything to sine and cosine.
Yeah. Does that not work?
I know, I'm writing it down. And it only doesn't work if, you can't quite make it work, right? And what are we calling our using? Just the sine and square root and cosine square root?
Yeah, I think so. Because then we can use sub, we can't use sub. I don't know.
Erase this bottom line. Or at least I personally found that bottom line, so it probably helpful. Anybody else work on this one?
I'm thinking u sub is tangent x and FDU equals secant squared x.
Okay.
So yeah,
Yeah, we're kind of missing the secant. I mean, we can force one into there by multiplying and dividing by secant. But then there's a secant in the denominator.
right. That would be secant x anyway.
Yeah. So I don't think this is quite helpful
Is there anything that we can't replace?
in terms of secant. What do you mean, Xavier?
Like the 1 minus
So this thing is equal to 1 minus secant squared.
So this is the cosine squared, cosine squared equals 1. Then we get the whole
Divide everything by cosine, right? So this is tangent. And then we subtract 1.
yeah.
So this is why I was kind of being super hesitant. You had your work kind of backwards.
Did
Not
I?
1 minus secant squared. It's
Oh,
secant
secant.
squared minus 1.
Yeah, sorry. Is that helpful or no?
Let me write it out first. Because it's definitely going to do something.
Is 9 plus secant squared to sub
Not quite, but the ones cancel out.
The ones cancel out.
I'll probably separate it into two separate angles.
What do you mean by that, Zach?
So you have, so you multiply the secant for this, you have 2 secant 1 plus secant 2, but separate them as separate angles. Over addition.
Alright, if you're going to do them separately, what's your first answer?
The first alternative would be secant, well, 2 secant x
Yeah.
plus c. But the c is good.
Yeah, let's wait on the plus c until we actually have to find the anti-groove. And what's the anti-groove secant cube?
I think we have that.
1/2, yeah, secant tangent plus the natural log, the absolute value of secant plus tangent, and the absolute value plus c.
And then we can put a plus c there. Oh wait, I think I did too many moves. There we go. That's all right.
So with the derivative method, in the base, just a bunch of,
Just a bunch of trig identities. Algebra work to simplify, and then trig identity to get rid of that secant square, not secant, to get rid of that tangent square. And then you can do a bunch of direct integration.
original question is don't integrate, but choose a method. Would you just make this method algebra? I don't know.
Algebra and trig identities.
Okay.
So 7.2 stuff.
Got it.
Right. That's sort of what like the intent of this one is going like, which section are you actually doing this out of? This would be 7.2. Right. This is technically like 5.5. Right, this is just straight up U sub. And so is this one. This one is partial fraction decomposition with some trig identity shenanigans. This one, I believe, is U sub and a trig sub.
I'm sorry, partial fraction?
Yeah, why is that partial fraction?
Oh, IBP,
Yeah, sorry.
my bad. Right, this is integration by parts, it's U sub. And because we have this algebraic term out here of t, we got cosine and sine.
Yeah.
So if we follow Light, t is u, dv is sine t, cosine t dt. U sub plus trig sub, straight U sub. What about this one?
Fractions.
Okay.
Yeah, because the derivative denominators one higher than the derivative.
So if you're doing partial fractions on this thing, right?
Yeah.
Presumably that means you factored your denominator.
Is that factorable?
Erica, you said, what's your factorization of that denominator?
Oh, I didn't do it. But
Oh,
I'm
okay.
assuming. I just assumed.
Hey, Hoang, you remember how to get your factorization, right? Because it is a cubic. What's up, Tommy? I'm not hearing the end of what you're saying.
I mean, like, it's not going to be a good number.
Not a nice number?
Yeah.
Well, we can at least get one.
We had a negative I.
A negative I. That would be funny. Is this Swedish? I think this is Swedish. I have a lot of language stuff on my calculator. Yeah, degree 3. And it's all ones, right?
Yeah.
Looks like we got one root here, -1. Yeah, synthetic division. Which brings up Hoang's other comment of it looks like the other ones are going to be I's. Yeah, if they were not I's, then they would have shown up here.
How do you find roots again without calculator stuff?
Without calculator stuff? Do you remember rational root theorem from pre-calc?
I don't think he covered it.
Okay. So where do I want to write from here?
That's like the normal one.
Unnecessary? I mean, if you don't have a calculator, it seems pretty necessary to me. I don't remember. So, if we have a polynomial in general form, and we want roots. There are very few methods that are actually available for actually figuring out roots. For general algebraic roots, once we get past degree 4, there is no like solid algebraic method of finding real roots. Because there is no such thing as like a quadratic formula type thing for degree 5. For degree 3 and degree 4, there is such a thing of like a quadratic formula. It's called cubic exponent. The formula is 2 lines long, typed up lines long. Quartic formula is 2 pages typed up long. And that's the reason why they did not teach you those in algebra class. And there is no such formula for degree 5 and above. What we can do, however, is instead of looking for real roots, we can look for rational roots. So we can look for roots of the form P over Q, where P and Q are integers. And there's a further thing that I'm going to assume here. I'm going to assume that P divided by Q has already been simplified as a fraction. So P over Q is not this. It'll be 1 over 3. P over Q is already simplified. Or the greatest common factor of P P and Q is 1. They share no common factors besides 1 to cancel. That's all I can simplify. I'm going to go ahead and plug this thing in, and we're going to assume that P over Q is a root. So when I plug it into this polynomial, I will get 0. So assume P over Q is a root. We have an, and it's time to see if I can't figure out this argument on the y, because I don't remember this. This should be. The only thing I remember is magic is going to happen here. Yep, so we assume P over Q is a root. We plug it in. Because it's a root, we get 0. I am going to clear my denominator, so I'm going to multiply everything by Q to the n. So I have an, Pn, an minus 1, Pn. I wrote it wrong up here too. Pn minus Q, A2, P2, Q, n minus 2, A1, P, Q, n minus 1, A0, Q, n equals 0. Yeah, no, I got it. I'm going to subtract over a and p to the n. That's 2, isn't it? It's a finite series.
So you doing calculator work by hand?
I mean, I guess so. And the thing that I'm noticing on the left-hand side is all of these terms have a factor of Q. Right, we got a Q here, we're gonna have Q things all in these ellipses. We got lots of Q's here, lots of Q's there, and our maximum of Q's there. I got Q's everywhere. So I factor out a Q. I have whatever is left over in here is equal to negative a n p to the n.
And it's just equal to the highest degree that we have in the original equation.
Yeah, in the original polynomial. And this is where this assumption is kind of important. Q was a factor of the left-hand side. And because these things are equal, that means Q must be a factor of the right-hand side as well. And Q cannot be a factor of p to the n because they have no common factors, which means Q must be a factor of an. It has to be. And we're going to come back up here, and instead of subtracting over a and p to the n, I'm going to subtract over a0 q to the n. When I'm done with that, over on the left-hand side, I have a p in every term, so I can factor out the p, and then it's the same argument again. P is a factor of the left-hand side, it's got to be a factor of the right-hand side, but that's this step, but negative. Can't be a factor from here, so it's got to be a factor from there.
So Q and P are a factor of a n.
No, that's not an, that's a0. So P must be a factor of a0. And this result gives us rational root test, or rational root theorem. I'm gonna erase all this stuff here. If I have a rational number, and if that rational number is a root, then what is true is that numerator must be a factor. This is p, so the constant term. And the denominator must be a factor of the leading coefficient. So in the case of whatever polynomial that we were doing, the only rational roots that it can have must have a numerator with a factor of 1 and a denominator with a factor of 1, which means it's either 1 over 1 or negative 1 over negative 1, or negative 1 over 1, or 1 over negative 1, which means we only have two choices. It's either got to be 1 or negative 1. Negative 1 happens to be over. Okay. But rational root theorem gets you this long list of potential rational roots, and you just get to have fun and test all of them until you find them, which is where some algebra teachers go, this is a little unnecessary. Because usually for general polynomials, that list of possible rational roots is like 26 numbers long. That's going to take you a long time to choose through every single one.
So this only for cube, not odds.
What do you mean?
Like for one, like one of the roots got to be 1 or negative 1. You know?
No, this is for every polynomial.
Oh. Okay.
Right, so this would be for, something like 6x to the 9th plus 8x squared plus 7x plus 5. Right? The only rational roots this thing is allowed to have is rational roots where we have a factor of 5 up top and a factor of 6 down below.
Oh.
So we got 1, negative 1, 5, negative 5, 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. So we're going to have 1, negative 1, 5, negative 5, 1 half, negative 1 half, 1/3, negative 1/3, 1/6, negative 1/6, 5 halves, negative 5 halves, 5/3, negative 5/3, and 5 sixths and negative 5 sixths as potential roots. And we just gotta go figure out which one it is.
Mm.
So that's what you would do if you didn't have a calculator. Sorry for the
Yeah, that's like a cheat code.
20-minute side tangent.
Yeah, my bad. I just didn't get this covered.
That's beautiful.
Let's go back to the original problem, right? We need to factorize this thing. And we know that x equals negative 1 is a root. This is where synthetic division comes from. So we have x squared plus 1. So my factorization is x plus 1, x squared plus 1. And so down the bottom, for the partial fraction decomposition, we're going to have a linear factor and an irreducible quadratic. So in our partial fraction decomposition, we get a over x plus 1 plus bx plus c over x squared plus 2. And then go through partial fraction decom.
Okay.
So like you've heard of the partial fraction.
Even though I got my own feet. I'm glad we ain't got no quiz. Oh, I should have asked him if we do it Monday. I'll email him. Oh. Even though I got my own TV and my own CD, I still the same old way. My legs hurt so bad, I literally just sat down for 4 hours at home stressing over that. Just to not even have nothing. Just add an extra stress on me and little too many. It just ain't right. It just ain't motherfucking right. Fucking legs hurt. I need a wheelchair. Ooh. I need a wheelchair. Ooh. Baby gonna come out with a tumor. That's a little tumor. I ain't got no baby. I don't know nothing about that queen. I don't know nothing about that. Y'all be hating. Y'all be mad. Y'all be mad. Oh. Morgan Wallen. Get your ass on. Even though I got my own baby and my own TV. I ate some tropical smoothie. Whew. We know we gonna be alright. No weapon formed against me is prospered here, man. People that really believe words have that much power are idiots. And 9 times out of 10, they don't be living life to the fullest. Cause they're literally idiots, literally. That's like them super religious Christians that like literally believe the word for word instead of deciphering it for your motherfucking self. Just dumb. Just fucking dumb. Just dumb. Just fucking dumb. Even though I got my own CD, my own TV, still the same old E. 'Cause even though I got my own TV and my own CD, still the same old E. 'Cause even though I got my own TV and my own CD, even though I got my own TV. Lord have mercy. In my own CD. Lord have mercy. Lord have mercy. Oh, it's music and definitely is. You gotta pay attention to them people that believe in them words that strong. And like the excuses they make for themselves when they in certain positions, amen. But I ain't gonna preach to y'all right now. I ain't gonna preach to y'all. I ain't gonna do it to y'all today. Oh Lord, what the hell is this? I ain't gonna preach today now. Not today. I ain't gonna preach today. I really could have stayed at home. I just ate. Hey, Queen. I'm finna restart this, though, because my phone glitching. I actually might sit here till 3 o'clock just to get my daily perking because I paid $3 to get here. I'm finna motherfucking get my $3 worth, honey. I promise I am. I promise I am. I swear you just had lashes. That's supposed to get here. I'm finna motherfucking get my $3 worth, honey. I promise I am. I promise I am. I swear you just had lashes. That's worth, honey.